Hello everyone, let's go ahead and take a look at congruent triangles. Now before we go ahead and take a look at congruence, what I'd like to do is I'd like to go ahead and review similarity because there is a relationship between these two, and if we review similarity I think we'll be able to make the connection to congruency much more simply. So let's first start off with similarity and reviewing that concept first. Let's take a look at these two triangles. It says we have a triangle ABC and a triangle DEF. Are these two triangles actually similar to each other? Well, we need to prove that. So let's go ahead and take a look at SAS, or side angle side. Now in order to go ahead and prove that two triangles are indeed similar to each other, we need to have a side, an angle, and a side, and a corresponding side, angle, and side. Now we know that the angle is a 90-degree angle, so we know that the corresponding 90-degree right angles are equal. And then we also need to show that the sides which contain that angle are in proportion. So 2 to 3 is equal to 2 to 3. And sure enough, that's going to work for us. So side angle side is going to prove that these two particular triangles are indeed similar to each other. Now once you go ahead and you prove that two triangles are similar, you can go ahead and expand your results to say that all corresponding angles are going to be equal. So the measurement of angle A is going to be equal to the measurement of angle D. We already knew that the 90-degree angles were going to be the same. And we also know that the measurement of angle C is going to be equal to the measurement of angle F. Now we already showed that two pairs of corresponding sides are in proportion. We could very well do the same thing for the hypotenuse if we wished. Now one other thing that I would like to go ahead and make clear is that notice that if we took a look at the scale factor to go from the small triangle to the large triangle, the scale factor would actually be consistently applied for corresponding sides. So if I say that the scale factor is going to be 1.5 or 3 over 2, if I take this side here and multiply it by 3 over 2, then the corresponding side length would be equal to 3. Same thing here, and again I could do the same thing for the hypotenuse. So once you establish that a triangle is similar, two triangles are similar to each other, you can find a lot of relationships between them. Now let's move to congruence. Now the first thing that you should notice that's different about congruency is the symbol. This is the symbol for congruency. And notice that it looks kind of like similarity in the sense that it has a squiggly line, and it also has the equal sign under it to represent a stronger relationship. Now, what exactly is that relationship? This is what it is. It says if two triangles are congruent to each other, then all corresponding angles are equal. And notice that's the same thing with similarity. But here's the stronger relationship. All corresponding sides are equal. So notice that in this case over here, the corresponding sides were in proportion. So what that means then is that when we're dealing with two triangles that are congruent to each other, we actually have mirror images of each other. The two triangles are mirror images of each other, as opposed to similarity, where one is a little bit larger than the other. Now, let's go ahead and think about how we want to go about determining whether two triangles are actually congruent to each other. We have 4 different ways. We can go ahead and show SSS. In other words, all 3 corresponding sides are equal. Or we can use SAS, which was similar to this, but instead of these sides being in proportion, we need to make sure that the corresponding sides are actually equal. It's the same thing for the angle side angle. And in this case over here, if we have a right triangle, if we have the right triangle, the right angle, the hypotenuse, and one side corresponding side being equal, then we can say that the right triangles are indeed congruent to each other. So let's go ahead and take a look at this particular situation here. I have this triangle ABC, and this triangle over here, DEF. Are these two triangles actually congruent to each other? Now, if we go ahead and take a look at the information that's presented to us, I have a side, an angle, and a side. I have a corresponding side, an angle, and a corresponding side. So, are the corresponding sides equal to each other? Well, it's 2 and 1, 2 and 1. And is the angle in between those sides equal to each other as well? And sure enough, they are. And because they are, I can say that side angle side is going to prove that these two triangles are indeed congruent. Now, again, notice that what we want to do is that when we go ahead and write congruence, we need to make sure, again, that there is correspondence in the sequence in which you write the notation. So in other words, if I have triangle ABC, it is going to be congruent to triangle FED because A corresponds to F, B, which is the right angle, corresponds to E, which is the right angle there, and C is going to correspond to D. Okay, so once we go ahead then and determine for a fact that two triangles are indeed congruent, we can then go ahead and say that all the corresponding angles are going to be equal, as well as all the corresponding sides being equal in length. Now the other thing that you should notice as well is that we still have a scale factor. Very much like similarity, we have a scale factor. Just notice that the scale factor in this case is 1. Okay, let's take a look at one last example. Let's say, for example, I have this triangle here, A, B, C, and D. Those are the vertices of the different parts. Notice we have one large triangle and it's cut up into two other right angled triangles. And we want to go ahead and find the length of AB. Now, most of the time I think people would say, oh, well, if this is the case, I know for a fact that those two triangles are indeed the same, or I should say these two triangles here are exactly the same, because this line right over here cuts this line AC, this side AC, directly in half, and therefore if BC is going to be equal to 3, then AB should be equal to 3 as well. Now, again, remember that in mathematics we need to be very precise. And what we need to do is we need to actually go ahead and state some of the reasons for why we know AB is going to be equal to 3. The easiest way for this particular situation is to first go ahead and show that the triangles are indeed congruent, and then we can show that corresponding sides are going to be equal. Let's take a look. If I go ahead and say that DB is equal to DB, well, that's the corresponding side of the triangle, and this triangle, because they're the same side. And I also know that triangle DBC, or DBC, is going to be equal to angle DBA, and both of those are going to be equal to 90 degrees. Now, how do I know that? Well, it's because it was given. Now, I also know that DA is going to be equal to DC. So DA is going to be equal to DC. So what I have then is because again that's given, and so what I have then is I can now say that triangle ADB is going to be congruent to triangle CDB. And what is the reason for that? It's because I have RHS, test for congruence, satisfied. So I notice that I have the right triangle, I have the hypotenuse equal to each other, and I have one of the sides also being equal to each other as well. Now, because I have established that ADB, so ADB, is congruent to CDB, then what I know then is that the corresponding sides are going to be equal, and therefore the corresponding side to AB is going to be equal to BC, or CB, which is of course being equal to 3, and therefore we know that AB is going to be equal to 3 as well, because we know that corresponding lengths of congruent triangles are equal. So let's go ahead and wrap up. Again, there are some very strong relationships, some very clear relationships between similarity and congruence, except for notice that congruence is a much stronger relationship because of all the corresponding sides being equal as opposed to being in proportion. We need to go ahead and remember the 4 tests for congruency to show that two triangles are indeed congruent, and once they are congruent to each other, then we can go ahead and use these 2 pieces of information to go ahead and determine desired angles or desired sides. Okay, so we will go ahead and take a look at some examples the next time that we're in class. So see you then. Bye-bye.